My name is Muskan Gupta, and today I'll be reviewing on the paper about security using hybrid cryptography algorithm. Moving to the introduction, the use of cloud computing has increased rapidly in recent years due to its cost effectiveness and scalability. However, this increase in cloud usage also brings security concerns. So, data stored in the cloud is vulnerable to cyber attacks, unauthorized access, and data breaches. So, the use of cryptography is essential for ensuring the confidentiality, integrity, and accessibility, availability of data that is stored in the cloud. Many studies have been conducted on the use of symmetric and asymmetric key encryption techniques for securing data in cloud. However, these techniques have their limitations, and there is basically a need for more comprehensive approach, to comprehensive approach to cloud file security. So, the purpose of this paper is basically to provide a hybrid cryptography-based approach for secure cloud file storage. The proposed approach basically combines both symmetric and asymmetric key encryption techniques to provide a high level of security with minimum overhead. So the paper also presents the benefit of the proposed approach and provides a detailed analysis of the experiment conducted to evaluate its effectiveness. The objective of this paper are to propose a hybrid cryptography-based approach for cloud file storage to evaluate the effectiveness of the proposed approach, to provide a detailed analysis of the results obtained from the experiment, to demonstrate the benefits of the proposed approach over the existing approach, and lastly, to present a solution for secure cloud file storage that can be used by organizations to protect their sensitive data. Talking about the scope of this project, proposed approach, the proposed approach is basically suitable for organizations that needs to store sensitive data in the cloud. The approach can basically be used to protect data from unauthorized access, modification, and deletion. The approach can be also be extended to provide additional security. Features. Talking about the security is in cloud computing. So, cloud computing has several benefits such as flexibility, scalability, and cost effectiveness. But it also possesses several security issues. The primary issue is the risk of unauthorized access to sensitive data, as third parties can have control over data in the cloud. The cloud storage providers can suffer from data breaches, hacking attempts, and malicious insiders. So the proposed multi-level cryptography-based security system for securing cloud computing addresses these concerns by using a new hybrid approach for symmetric and asymmetric key algorithms. Now I'll talk cryptography. So cryptography manages the security of data or stored data basically or communicated over the cloud network. So cryptography in the cloud basically uses encryption method to secure data from unauthorized access. So cryptography is basically carried out in two different phases, that is encryption and decryption. Encryption is a process of converting plain text or secret messages into a ciphertext with the help of a secret key. Whereas decryption is the process of converting ciphertext into plain text with the help of same key using the encryption process. Now I'll talk about symmetric and asymmetric key encryption. So in symmetric key encryption, the message is basically encrypted by using a key, and that same key is used to decrypt the message. Whereas symmetric key encryption is based on public and private key encryption techniques. The public key is used to encrypt the data, and the private key is used to decrypt it. Asymmetric key encryption is way more secure than asymmetric key encryption technique because the private key is usually kept secret by the owner. So this paper mainly focuses on the hybrid cryptography based approaches. So hybrid cryptography is basically a technique that combines both symmetric and asymmetric key cryptography to provide a high level of security with minimum overhead. Um, in hybrid cryptography, symmetric key encryption is used to encrypt the data, and asymmetric key encryption is used to encrypt the symmetric key. The data is first encrypted using a symmetric key, and then the symmetric key is encrypted using the public key of the intended recipient. The encrypted data and the encrypted symmetric key are then stored in the cloud. So when the recipient needs to access the data, the private key is used to, decrypt the encrypted symmetric key, and then the symmetric key is used to decrypt the encrypted data, as shown in the picture. So this combination of symmetric and asymmetric key and encryption basically provides a high level of security for cloud file storage. So the proposed hybrid cryptography module in this particular paper basically combines both DES and RSA algorithms. So I'll just simply go through both DES and RSA one by one. Um, DES, data encryption standard algorithm, is a widely used encryption algorithm that was developed in the 1970s. So basically, it is a symmetric key algorithm, meaning that the same key is used for encryption and decryption. So the encryption method of this is quite unique, because as it receives a 64-bit plain text at the sender's end and a 64-bit text at the receiver side. In DES, although the key size is 64-bit, only 54 bits are basically used for encryption and decryption. So DES is based on the concept of Fitzer cipher implementation and basically uses 16 routes of Fitzer structure as shown in the diagram, which helps to generate a 48-bit unique key from the cipher. So initially 64-bit, 64. Um, Initially, 64-bit permutation is performed on a six subblocks, represented as L0 and R0 that are then passed into pixel rounds. So this process will repeat until the 16 rounds of the encryption method. And as the number of two-fold increases, the security level also increases. In the last round, that is 16th round, the pre-output is generated by swapping both the len15 and r15 bit quantities. Finally, the inverse function of our initial permutation is calculated by simply concatenating that is R15 and L15 bit values. Next up we have RSA. So RSA is an asymmetric algorithm that works on two separate keys, that is private key and public. So private key, the public key is basically shared by all, but the private key is kept secret as the user uses. So RSA works on positive integer prime numbers that are exponentially used for the encryption and decryption process. So RSA works by first generating two large prime numbers P and Q as shown in the image, and then computing their product, which is n equals to P into. Next up, we calculate this product. Basically, the n is used as the modulus for both the private and public key. We'll look into that later on. So next, a number E is chosen that is relatively prime number to the to hyphen of n, which is p minus q1 into q minus. So this number E is used as the public key, and the number D is used as the private key. So the D, which are both calculated using a modulo inverse of the E mod, I guess P minus 1, Q minus. Here, and see has shown in the screen, I use as plain text and ciphertext respectively to define the encryption and decryption procedures that is shown in the image. To encrypt a message using RSA, the message was converted into a number and then raised to the power of the public key E modulo n. To decrypt a message using RSA, the recipient uses the ciphertext raised to the power the public private D modulus modulo n, which recovers the original research method. So the author basically the authors have proposed a new approach for securing files in cloud computing environments using hybrid cryptography algorithms. So basically, they describe the design implementation of their approach and evaluate its performance in terms of security and efficiency through experiments. So the approach is uses DSA, DES for so the approaches basically uses DES for encrypting and decrypting large files and RSA for encrypting and decrypting the DES file, which is used for encryption and decrypting the file. Talking about the proposed approach, so the proposed approach uses a four-step process for file encryption and decryption. First, the file is compressed and encrypted using the DES. Second, the DES key, um, as see cursor, the the DES key is encrypted using the DES. Third, the encrypted file and the encrypted DES key are stored with cloud storage. And finally, the fourth step, the encrypted file and the encrypted DES keys are downloaded from the cloud storage and decrypted using the RSA and DES keys. So the authors basically conducted various experiments to evaluate the performance of the proposed approach. Um, so the authors conducted experiments to evaluate the performance of the approach in terms of encryption and decryption time, key generation time, file upload or download time. So the experiments were basically conducted on a local network and in a cloud environment using AWS, that stands for Amazon Web Services. Moving on to the results and conclusion of this video. So this proposed model or approach basically uses two separate cryptography algorithms as I talked earlier, that is RSA and DES. So, so the main purpose for using combining both of these algorithms was to increase the security of cloud storage. So the model basically ensures data privacy and confidentiality during the transmission stage, preventing data loss, privacy risks, government intrusions, and spying efforts. So basically, by encrypting the data at the client side before uploading it on the cloud storage service, an extra layer of security is basically added to the data, which fulfills the main aim of this algorithm, which is to secure data while in transit state. Moreover, the result of the experiments show that the proposed algorithms provide a high level of security with minimal overhead and is suitable for use in the cloud environments. Lastly, the conclusion of this paper is that the proposed hybrid cryptography algorithm provides a secure and efficient solution for protecting data in the cloud. The paper basically demonstrated the effectiveness of the proposed algorithm by conducting experiments on large data sets, and the results showed that the proposed algorithm provides better security than other existing encryption algorithms. Moreover, the paper concluded that the proposed hybrid cryptography algorithm can be used to secure sensitive data in the cloud and can be a useful solution for businesses and organizations that wants to ensure the security of their data. Thank you.